Alright, and welcome back. This is going to be our last video for this first introduction to hypothesis tests. And again, it's covering chapter 20 in the Statistics Modeling Our World curriculum. The last thing we want to talk about here are two things. We want to talk about this different alternative hypothesis, and we're also going to talk a little bit more about p-values in this particular video. So, in the examples that we've done thus far, we have used a less than or a greater than situation. There's actually three different types of alternative hypotheses you can have, though. You can use a less than or a greater than, but you can also use this one that is a does not equal. And the does not equal to alternative hypotheses are when we're looking in possible deviations on both sides of a particular value. Okay, so we would use does not equal when we have a situation where either we're thinking the value could be above or below, or when the context of the problem does not state a specific we think the value is larger or we think the value is actually smaller. We would use it when there's sort of that ambiguousness to it, when it could be bigger or smaller, or as it says here, in either direction from the null hypothesis value. And when you do this in a single tail test, just to look at the picture of the single tail, on a single tail test where we use the less than or greater than, we're only measuring one side, right? This red space down here, that red space is your p-value. That stuff right there is your p-value, that area, okay? On a one-sided test, we're just measuring the one side. This would be a less than. This would be a less than test. P is less than this because we're measuring that space here and more extreme than that to the left. When you do a does not equal to test, you're looking for those deviations on both sides. So you're going the same number of z-scores out to the left and the right, or the number of standard deviations. In this case, it looks like it's 0.03. So they went 0.03 to the right and 0.03 to the left. And notice that we measured this tail and this tail. So we call that a two-tailed test. And when we're measuring our p-value, we take these two numbers and we add them together. So in this case, the p-value would be 0.069 plus 0.069, and that would be our overall score. And so when we do a two-sided test, it does, because we're looking at both sides, that does typically mean we're always going to have a p-value that's a little bit higher than an equivalent one-tailed test. So we have to kind of keep that in mind when we are finding our p-values. And again, a one-sided test again just shows that this one side, again, it's called a one-sided alternative or a one-tailed test, and it's just focusing on the direction that the inequality sign here states. So this picture right here that has this p-value is a less than test, whereas if we were to have something over here measuring this side, this would be a greater than test because we're looking for the deviation to the right of that spot. So an example of where you might use a two-sided test, notice that on this particular problem, there are supposed to be 20% orange M&Ms. Suppose a randomly selected bag of 122 has only 21 orange ones. Does this contradict the company's 20% claim? You could easily make an argument that you could use does not equal to, or a, let's see, 21 out of 122, I believe is larger. So we could use a, let's double check that. You know, I've been making nothing but mistakes in my videos recently, so let's just make sure. No, that's smaller. See, look at that. So you can make the argument that you could use a one-tailed or a two-tailed for this. The one-tailed, because we have a proportion that's definitely smaller than 20%, we could make the argument that we could just do a one-tail on this because we are looking at a p-hat sample proportion that is smaller. On the other hand, we could make the argument that because it says, does this contradict the company's claim, as there's no specific question saying, is it definitely smaller, is it definitely bigger? It's just, does it contradict? It says it could be, it's ambiguous as it's less than or bigger. Then we could make the argument to use a does not equal to. When they do this sort of thing on the AP test, they will generally accept both answers as long as you follow through the process correctly. Okay. So I'm going to skip through a couple of problems here, and then we'll look at this last thing about p-values. And so we're going to talk more about this in chapter 21, but the question becomes, how small should a p-value be in order for you to reject the null hypothesis? Well, we did say in general, 0.05 is a safe time to reject the null hypothesis. However, there's a lot of context here that can change whether or not what threshold we should set. So for example, when we're screening for a disease and want to be sure that we treat all those who are sick, we may be willing to reject a null hypothesis that is a little bit larger. And the reason why we would do that is because we would reject less of them if we made that number a little bit higher. And so we're allowing for a little bit more flexibility so that more people get treated. Okay. However, if it's something that's like a long-standing hypothesis believed by many to be true, if we're going to change opinions on that, we need stronger evidence. And correspondingly, because we would need smaller evidence, we would want a much smaller p-value. So we might set the p-value to be like 0.01 instead of 0.10. This would mean that we would reject a lot more of them. Now, in chapter 21, we're going to talk about the consequences of that, right? In terms of like what we call type 1 and type 2 errors. But for now, we're just recognizing that if we make the p-value higher, we will reject less null hypotheses. Therefore, if we're wanting to sort of accept things so like more people get treated, or if it's something that's not that important, M&M value, is the proportion of M&Ms correct? Well, we may be willing to accept less strong evidence if it's not something that's super important. But if we need strong evidence, or it's like lives are on the line if we mess this up. The example that I always give is, we're testing the tensile strength of rivets in an airplane. Okay, we don't want to accept small evidence, right? We don't want to accept a lot of different evidence. The strength of that rivet has to be very specific, because if that rivet fails and the plane falls apart while it's in the air, people die. And so you want to have a much smaller p-value in that case, because if you were to reject the null hypothesis when you should have kept it, there's lives on the line. It's very important. We need very strong evidence to make that happen. Therefore, we want a very small p-value to go with it. So for every different test, that threshold will be different. And you kind of have to, when you're actually doing research on this, and using these techniques when you're researching, you have to be very careful in choosing which threshold of evidence is okay. AP land, AP test, they will generally tell you what you need to do. And again, it's called the alpha value, and we're going to talk about that in chapter 21. But they will generally tell you what that is, so that you make the correct decision for what's on the AP test. They really guide you on the AP test so that you don't make these mistakes. But the reality about the research involved is there's flexibility, and this is one of the difficulties in how these things get misused so often, is that there's a lot of confusion as to what a p-value means and what the threshold is, and the fact that you can change it around. That journalists and people don't look for those things. This is why we need to be statistically literate, so that we know that. Okay. And then I already kind of talked about that. So let's go to the next slide. Your conclusion about any null hypothesis should be accompanied by the p-value of the test. If possible, you should also do a confidence interval. Again, the purpose of statistics is not to what's the word I'm looking for, to fool people, right? And as a statistically literate person who's reading research about these things, this is the stuff that you have to ask for. You need to ask for what the p-value is. You need to find out their confidence interval. You will need to find out about their methodologies. Otherwise, it could be that a piece of research that you're looking at is just completely biased and not worth it. You, as a researcher who is attempting to be as upfront about these things as possible, should be including this information in what your research is, right? You need to state the p-value, state whether or not, you need to state the level of, that your threshold of evidence that you're keeping, and then, yeah, give a confidence interval because it just gives more information to the person who's reading that research. Again, AP land is different, okay? AP land looks for those things in a conclusion that we talked about, right? Remember, take a crap, or take a craps. It needs to be in context. You need to state whether you're rejecting or fail to reject. You need to assume significance, which we'll talk about in chapter 21, but it's basically what level or what threshold of evidence am I accepting? And then you need to state your p-value. If you do all of those things in a conclusion for the AP test, then you're fine. Okay. And again, yeah, don't just claim it to be rejected or not rejected. State what the p-value is. It tells you the strength of the evidence. Because if the p-value, if the threshold that you're taking is 0.05 and the p-value you get is 0.049, you're still rejecting the null hypothesis. But because it's so close to that threshold, it's strong evidence, but it's not that strong of evidence, right? So you want to state that p-value so that you can let the reader decide whether or not it's appropriate to reject the null hypothesis, right? You state your information and let the readers decide whether or not your conclusion that you reached is appropriate. Okay. All right, and I believe that is it that we have for chapter 20. If you've got questions, comments, concerns, you can throw them in the comments below and I will try to address them. Otherwise, thank you for watching. Bye.